our discussion was going on with proofs. So one new method for proofs is proof by mathematical induction. So mathematical induction के जरिए proof करना is quite one important way of proving. बहुत ज़्यादा हम use करते हैं इसको mathematical induction के जरिए चीज़ को prove करना. So mathematical induction में there are certain steps that we follow and we show it if the given statement is true. उसमें we have to be careful of one thing. जो हमारा domain set है, जो हमारा universe of discourse है, जो हमारा जिस domain में हम बात कर रहे हैं, हमारा domain set, input set आप उसको कह लें. So it should be well ordered. Well ordered का मतलब ये होता है कि जो pattern उसका शुरू में है वही उसका throughout आखिर तक वही pattern चलता है. For example, set of integers is well ordered set. Well ordered इसमें एक proper order है. 1 के बाद next number is 2, 2 के बाद 3, 3 के बाद 4. इस तरह अगर आप कहीं दरम्यान में भी चले जाएं, so it will be the same pattern. You can always tell कि what will be the next number. Pattern is known. कि अगर आपको 100 है तो you will always know कि what will be the next number. 101. Then next number will be 102 and so on. Similarly, a set of even numbers, odd numbers, integers, they are well ordered. आपको पता है कि अगर मेरे पास 2 है, 2 के बाद 4 होगा, 4 के बाद 6 होगा, 6 के बाद 8 होगा and so on. So even you are given a very big number like 2458, so you will tell what will be the next number. It will be 2460. Same thing with odd number. या कोई भी और हो सकता है जिसमें एक pattern is well known और जो शुरू में pattern है वही end पे है. So if you are standing somewhere in the middle, you can always tell what will be the next number. So this is quite important for these proof techniques of mathematical induction. कि जो आपका domain set है, it should be well ordered. इसमें होता क्या है? So if we are given a statement, उसको हम conjecture का नाम देते हैं. So if you are given a conjecture which we need to prove, so हमारी statement दी हुई है कि this statement is true for this certain domain set. So we have to prove it. So हम कहते हैं क्या है, सबसे पहले तो उस डोमेन सेट की शुरू की वैल्यू के लिए देखते हैं. शुरू की वैल्यूज के लिए ये क्लेम ठीक है कि नहीं है. Suppose if it is for positive integers, so positive integers 1 2 3 4 5. So we see कि जो हमारी given statement है, क्या ये n is equal to 1 के लिए ठीक है, पहली वैल्यू के लिए ठीक है. अगर पहली वैल्यू के लिए false हो गई तो फिर तो सारा क्लेम ही false हो गया. We don't have to go further. So we have to check it whether it is true for the first value. This is called base step. Base हम base पे check कर रहे होते हैं. So next is our inductive step. Inductive step consists of two sub steps, I should say. हम कहते हैं कि हम अगर कहीं दरमियान में खड़े हैं n is equal to k के लिए. Suppose we make a hypothesis. Inductive hypothesis. Suppose the given statement is true for certain value of n. For certain value of n, let's suppose call this certain value equal to k. So the claim is true for k. We have to show whether this given claim, given conjecture is true for the next value k plus 1 or not. तो अगर तो k के लिए true है तो फिर k plus 1 के लिए भी true होने चाहिए. Then we can say कि the statement is true for any value. अगर k plus 1 के लिए ठीक नहीं है, so then we cannot say it's true. So it has to be true for k plus 1. When we will do examples, it will be more clear. It's actually this analogy is just like if we want to climb up on a stair and we don't know how to climb up stair, and someone comes and he tells us this is the way how to climb up stair. Stairs or ladders. So instead of teaching us how to climb up the whole staircase or the ladder, the person is just teaching us how to take the first step, and after first step how to take the second step, and that's all. ये आपकी ladder है, and you have to carry your foot and put it on the first step, and then you climb up the first step, and then you put your foot on the next step, and you climb up to the next step. ठीक है, ये चीज आपको अच्छी तरह आ गई. So this is like base case, and then someone blindfold you and make you stand up somewhere in the middle on the kth step, and they just take कि आपको एक step लेना आता है, we have taught you how to take one step. So just take one step, and you take one step, so you will reach k plus one step. Because जितना गैप शुरू के रॉड्स ऑफ द लैडर में है, उतना ही गैप बाद के रॉड्स में भी है. सो इट्स लाइक वेल ऑर्डर्ड. जिस तरह आपने पहला स्टेप लिया, जितना गैप है, द सेम गैप इज देयर on the k from kth step to k plus one step. So induction में यही होता है कि आप बेस केस को शो करते हैं, and then you are standing somewhere like on the kth step, and we suppose कि अगर ये k के लिए ट्रू है, then k plus one के लिए भी ट्रू है. अब ये k की वैल्यू हो सकता है आपकी पहली वैल्यू हो. अगर पहली वैल्यू की ट्रू है, we show it for second वैल्यू. अगर k की वैल्यू अब सेकंड वैल्यू, so we show it for third वैल्यू. अगर k की वैल्यू थर्ड वैल्यू, we show it for next fourth value and so on. So अगर हमने ये शो कर लिया, एक तो बेस स्टेप के हाँ शुरू में ये चीज ठीक है, and we assume के our set is well ordered set. तो फिर k से from k to k plus one it should be true. So this is like an implication. If it is true for k, then it should be k plus one. और इस implication को हमने prove करना होता है, इस implication को हमने show करना होता है. So let's formally define induction, and then we can do some examples. Okay, fine. So principle of mathematical induction में क्या है कि to prove our statement. So statement depends on some number n. So prove that our conjecture, our statement P, is true for all. Suppose if we are talking about positive integers, it could be some other value. So suppose it is for positive integers. So अगर हमने show करना है कि हमारा claim, our statement P is true for all positive integer n. So then we have to do two steps. वो दो steps क्या है? पहला है base case, base step. So base step is कि we check whether the statement is true for the first value of n or not. अगर n की value 1 है, so we have to show P of 1. कि हमारी statement P, it is true for n is equal to 1. So ये show करना important है for the first value, because अगर first value के लिए true नहीं है, तो फिर हमारा सारा claim ही false हो गया. We do not go further. So अगर पहले step के लिए true है, then we go to the inductive step. So it consists of two parts. First, we make hypothesis. Suppose the statement is true for n is equal to k, like P of k is true. So then we show if P of k is true, then P of k plus 1 is true. So this is an implication. P of k implies P of k plus 1. P of k is our hypothesis. And based on this hypothesis, we have to conclude that P of k plus 1 is true. So जिस तरह हमने पहले prove किया था, अपनी implication prove करने के लिए, whether with direct proof or indirect proof, so उस तरह हमने prove करना है कि P of k, we suppose that it is true. So अगर ये true है, then we do certain mathematical steps, logical steps, and then we show that it is also true for P of k plus 1. So in short, if P of 1 is true and it is true for all k, P of k implies P of k plus 1. ये implication आपका inductive step true है, आपके base case true है और आपका inductive step true है. Then we can conclude that statement is true for all values of n. कि देखें अगर P of 1, k की value 1 है, तो हमने k plus 1, k की value 2 के लिए भी true show कर लिया. k की value अगर 2 है, so हमने k plus 1, 3 के लिए show कर लिया. k की value 4 है, हमने k plus 1, 5 के लिए show कर लिया, and so on. We can go till the last value of n. So it's true for all values of n. The claim is true. Let's do some examples, but before examples, just what we are saying is just like a domino effect. अगर आपके पास set of dominoes हो, and if we strike kth domino, then it will make k plus 1 fall down and so on. So it will keep on going. So it's just like this. So if we make one domino fall and it is well ordered कि उन सब के दरमियान गैप एक सही है. So अगर पहला domino second को fall down करेगा, second will make third one fall down, third will make fourth one fall down, and so on. So it will keep on going till the end. So अगर हमने k के लिए show कर लेते हैं अपनी statement को, so it means we have k से k plus 1 के लिए show कर लेते हैं, so it means k plus 1 से k plus 2 के लिए भी show हो जाएगी, k plus 2 से k plus 3 के लिए भी show हो जाएगी, following the same process. Let's do some examples, it will be more clear. So here it is one statement, one conjecture. Show that for positive integers n, so if we have n positive integers, so their sum is equal to n into n plus 1 divided by 2. हमारे पास n positive integers हैं, उनको अगर हम ऐड करें, so the sum is equal to n into n plus 1 divided by 2. इस तरह की चीज हमने काउंटिंग में शुरू में भी की थी. So 1 plus 2 plus 3 plus 4 up till n is equal to n into n plus 1 divided by 2. So हमने करना क्या है, पहले हमने बेस केस के लिए शो करना है, means n is equal to 1 के लिए. फिर हम कहेंगे कि suppose it is true for n is equal to k, then we have to show कि अगर n की वैल्यू k plus 1 हो तब भी ये रिलेशनशिप एग्जिस्ट करेगा, ये रिलेशनशिप वैलिड होगा. So we have to show it. Let's see. So the first step is the base case. So our domain set is set of positive integers. So set of positive integers is z plus is equal to 1, 2, 3, 4 and so on. So set of positive integers starts with 1. So इसमें हमारे पास जो पहली वैल्यू आ रही है डोमेन सेट की, that is equal to 1, n is equal to 1. So base case हमने शो करना है. Base case के लिए we start from n is equal to 1. So if n is equal to 1, then left hand side n is equal to 1 means हमारे पास एक ही इंटीजर है. So एक इंटीजर को अगर हम सम भी कर लें तो it will be the same value. So if we sum one integer, so left hand side is equal to just 1. हमारे पास सिर्फ एक इंटीजर है. राइट हैंड साइड क्या ये फार्मूला वैलिड है? लेट्स सी. सो n की जगह 1 को पुट कर दें राइट हैंड साइड में, सो इट विल बी 1 into 1 plus 1 divided by 2. 1 plus 1 is 2, so 2 divided by 2 is equal to 1. So left hand side is equal to right hand side, so it means the base case is true. The case is true. Base case most of the cases में एक base case show करना काफी होता है. For your own satisfaction, for you कि क्या वाकई हम ठीक डायरेक्शन में जा रहे हैं, you can check for the next value of n as well. अगर हमारे पास n की वैल्यू 2 हो, it means we are summing up two integers. 1 plus 2 is equal to 3. So right hand side पे क्या होगा, 2 into 2 plus 1 divided by 2. 2 into 3 divided by 2. 2 2 से cancel हो गया, we will get 3. So 3 is equal to 3, that's true. Same thing will be n is equal to 3 and so on. But in general, it is enough to show one base case. एक base case show हो गया. So let's move to hypothesis. Hypothesis क्या है? Suppose the given expression, ये जो ऊपर हमने expression दिया हुआ है, suppose this given expression is true for n is equal to k. कि ये जो given expression है, it's true for n is equal to k. So if it is true for n is equal to k, so it means we can replace n by k. So this will become 1 plus 2 plus 3 plus k. हमारे पास k integers हैं, उनको ऐड किया, so this should be equal to k into k plus 1 divided by 2. So हम suppose करते हैं कि ये true है. अगर ये true है, so our statement, let's call it p. So p of k is true, then p of k plus 1 should be true. We need to show that if p of k is true, then p of k plus 1 is true. So p of k तो हमारा hypothesis हो गया. P of k plus 1 वो हमें अब शो करना है. Let's show it. So hypothesis 1 plus 2 plus 3 up till k. So suppose this is true, then we have to show that expression is true for n is equal to k plus 1. n is equal to k plus 1 के लिए हमारा expression true है. So you can do it in two ways. You can start from left hand side and just make it equal to right hand side, या हम ये कर सकते हैं कि जो हमारा hypothesis है इसके दोनों साइड पे हम k plus 1 को ऐड कर लें. So let's start from the left hand side. So left hand side पे अब हमारे पास पहले k इंटीजर थे, तो अब हमारे पास k plus 1 इंटीजर है. तो sum of first k plus 1 integers. So 1 plus 2 plus 3 plus up till k plus 1, yeah, 1 plus 2 plus 3 plus k plus 1. k plus 1 से पहले इंटीजर k ही होगा. So ये हमारे पास एक समेशन है फर्स्ट k plus 1 इंटीजर्स की. हमने सपोज किया था कि हमारा हाइपोथेसिस ट्रू है. तो हाइपोथेसिस क्या है कि हमारे पास जो पहले k इंटीजर्स हैं उनका सम, this sum is equal to k into k plus 1 divided by 2. 1 plus 2 plus 3 plus k, this is equal to k plus 1, k into k plus 1 divided by 2. हमने ये सपोज किया था कि ये स्टेटमेंट ट्रू है. for k n is equal to k, this expression is true. जहाँ पे हम देखते हैं कि 1 plus 2 plus 3 plus k plus 1, so शुरू में हमारे पास k इंटीजर्स हैं और उसमें फिर हमने k plus 1th इंटीजर ऐड किया. So शुरू के k इंटीजर्स की वैल्यू तो हमें हाइपोथेसिस से मालूम है. So from hypothesis we know the value of 1 plus 2 plus 3 up till k is equal to k into k plus 1 divided by 2. So it means जो पहले k इंटीजर का सम है उस जगह हम k into k plus 1 divided by 2 सब्स्टिट्यूट कर सकते हैं. So we substitute this thing. So we get k into k plus 1 divided by 2 and then plus k plus 1. Now this is simple algebraic manipulation. K plus 1 आप common ले लें, so it will be solved. या LCM ले लें. So we take LCM. So this is k into k plus 1 plus 2 times k plus 1 plus 2 times k plus 1. इसमें k plus 1 we see it's common, take it out as common. So this is k into k plus 1 divided by 2. Which we can also write it down like if we want to show it just like that, it is same expression as the given one with n is equal to k plus 1. So we just write it down, k plus 1 into k plus 1 plus 1, k plus 1 plus 1. Okay. So so it is the same expression as the given expression जो हमारे पास क्वेश्चन में दिया हुआ है. सो उसमें जस्ट n की जगह हमारे पास वैल्यू k plus 1 आ गई. So this is n into n plus 1 divided by 2. So this is the same as right hand side of the given expression with n is equal to k plus 1. So it means left hand side is equal to right hand side for n is equal to k plus 1. So if the statement was true for k, it's true for k plus 1 as well. So it means it is going to be true for all values of n. I will repeat the whole process again, the whole procedure again for this question. So question is k sum of us n integer is equal to n into n plus 1 divided by 2. So इसको हमने mathematical induction से show करना है. So the first step is base step. Base step, so it is for positive integer. So first positive integer is 1. If n is equal to 1, तो फिर हम ये देखते हैं कि लेफ्ट हैंड साइड और राइट हैंड साइड हमारे एक्सप्रेशन की सेम है कि नहीं है. n is equal to 1 means हमारे पास एक ही इंटीजर है. So एक इंटीजर, so that is 1. So left hand side is just 1. Right hand side पे क्या होगा, 1 into 1 plus 1 divided by 2, which is 2 over 2, which is 1. So right hand side and left hand side are same. So base case is valid. So the given expression holds for the base case. Base case most of the time एक base case show करना enough होता है. Don't go for the 2, 3. I mean it will just you can show it obviously, but like it is just wasting your time. So let's look at the hypothesis. So inductive step का पहले step ये होता है कि हम hypothesis बनाते हैं. So we suppose कि जो given expression है it is true for n is equal to k, some value k. k की वैल्यू कुछ भी हो सकती है. k की वैल्यू 1 हो सकती है जो हमने अभी शो किया, k की वैल्यू 2 हो सकती है, 3 हो सकती है, या कुछ भी दरमियान में हो सकती है. हमने ये शो करना है कि अगर हमारा क्लेम k के लिए ट्रू है तो ये k plus 1 के लिए भी ट्रू होगा. So if p of k is true, then p of k plus 1 should be true. Implication यही होती है ना कि अगर आपका hypothesis true है तो conclusion भी true होना चाहिए. So hypothesis हमने suppose कि it is true, then we have to show that conclusion p of k plus 1 is true. So for inductive steps, so we assume, so we take n is equal to k plus 1. Okay, let's see n की अगली वैल्यू के लिए क्या ये एक्सप्रेशन अभी भी वैलिड है कि नहीं है. So हमारी लेफ्ट हैंड साइड क्या है, 1 plus 2 up to n. n की वैल्यू अब हो गई k plus 1. So it means it's sum of first k plus 1 integer. So 1 plus 2 plus 3 plus 4 plus k plus 1. हमारे पास k plus 1 इंटीजर्स हैं, इनका सम. इसमें जो पहले के इंटीजर्स हैं वो तो हमारे पास हाइपोथेसिस से उसकी वैल्यू हमें मालूम है. हमने ये अज्यूम किया था ना कि हाइपोथेसिस इज ट्रू. So it means जो first k integers हैं उसकी value from hypothesis we can take k into k plus 1 divided by 2. So this becomes k into k plus 1 divided by 2 plus k plus 1. So we take LCM and then simplify it. K into k plus 1 plus 2 times k plus 1 divided by 2. K plus 1 common multiple hai. So k plus 1 into k plus 2. So k plus 2 is k plus 1 plus 1. So it's just like n into n plus 1 divided by 2, where n is equal to k plus 1. So left hand side is same as right hand side. So it means P of k implies P of k plus 1. हमारा inductive step true है. So the given expression is true. According to mathematical induction, the given statement expression is valid, it's true. Let's do one more example. So this example says sum of powers of 2, n powers of 2 is equal to 2 raised by n plus 1 minus 1. For all non-negative integers n. Non-negative integers means we start from 0. Non-negative integers, so they start from 0, 0, 1, 2, 3, 4, and so on. So powers of 2, 2 raised per 0 is 1, plus 2 raised per 1, plus 2 raised per 2, plus 2 raised per n. So sum of first n powers of 2, including 0th power. So this is equal to 2 raised per n plus 1 minus 1. 2 raised per n plus 1 minus 1. So इसको हमने शो करना है. So ABC, like if हमारे पास एक इंटीजर है, so 1, दो इंटीजर्स हैं, n की वैल्यू 2 है, तो 1 plus 2 is 3. तीन इंटीजर्स हैं, तो it is going to be 1 plus 2 plus 4, 7, and then 15 and 31 and 63 and so on. यानी total sum is going to be 2 raised per something minus 1. उससे एक कम रहता है. तो जितना actually 2 n की पावर है, उससे अगली पावर और उससे एक कम. So it is used in binary number, we use in binary numbers, binary system, powers of 2. So let's show this expression. So base case is for n is equal to 0, non-negative integers, so we start from 0. For n is equal to 0, so left hand side is 2 raised per 0 is 1. So we have just only one power, so 2 raised per 0 is equal to 1. Right hand side, so 2 raised per n plus 1 minus 1. So 2 raised per 0 plus 1 minus 1. 2 raised per 1 minus 1. So 2 minus 1 is equal to 1. So left hand side is same as right hand side. Left hand side is equal to right hand side. So we make hypothesis. Suppose the given expression is true for n is equal to k. हमारे पास कोई वैल्यू n की k है जिसके लिए हम suppose करते हैं कि it is true. So then the given expression is 1 plus 2 plus 2 square plus 2 raised by k is equal to 2 raised by k plus 1 minus 1. So just हमने n को k से replace कर दिया. So पहले जो k integers है non-negative integer, उसके लिए given expression suppose it is true. अगर k के लिए true है, we need to show कि k plus 1 के लिए भी true होगा. ये हमें अभी show करना है. So we need to show it. So let's show it. So based on hypothesis, this is quite important. जब हम अपने inductive step में we use hypothesis, क्योंकि हमने ये कहा है कि हमें show करना है कि p of k implies p of k plus 1. Hypothesis show use किए बगैर we cannot show p of k plus 1. We have to use the fact of p of k for p of k plus 1. So inductive step, let's show the expression is true for n is equal to k plus 1. So we have got first k plus 1 powers starting from 0. So 1 plus 2 square plus 2 raised by k, और इसके अंदर हम k plus 1 power ऐड करें plus 2 raised by k plus 1. ये सम किसके बराबर होना चाहिए? So from the given expression it should be equal to 2 raised by n की वैल्यू k plus 1. So k plus 1 means 2 raised by k plus 2 minus 1. वहां तक हमने जाना है. So left hand side is 1 plus 2 square plus 2 raised by k plus 2 raised by k plus 1. लेकिन हमें hypothesis से मालूम है कि जो पहली up till 2 raised by k ये जो summation है, this is equal to 2 raised by k plus 1 minus 1. So we know the value of first 2 raised by k power, sum of 2 raised by k तक का जो sum है उसकी वैल्यू हमें मालूम है. So we just substitute its value 2 raised by k plus 1 minus 1 and then plus 2 raised by k plus 1 जो हमारे पास ऊपर से आ रहा है. So this will become 2 raised by k plus 1 और 2 raised by k plus 1 ये दोनों ऐड हो रहे हैं. So it's just ये दोनों एक ही चीज हैं. So it's just like x plus x is equal to 2x. So this become 2 times 2 raised by k plus 1. 2 raised by k plus 1 plus 2 raised by k plus 1 दोनों एक ही चीज हैं. So it become 2 times 2 raised by k plus 1 और minus 1 उसी तरह हमारे पास आ गया minus 1. So 2 times 2 raised by k plus 1 minus 1. 2 times 2 raised by k plus 1. So बेस सेम है तो पावर्स ऐड हो जाएंगी. ये 2 raised पर 1 है और ये 2 raised पर k plus 1 है. So 1 plus k plus 1 we get 2 raised by k plus 2 and minus 1 इसी तरह. So this is the expression that we needed. So 2 raised by k plus 2 can be written as 2 raised by k plus 1 plus 1. So n की value k plus 1 के लिए it's same as the right hand side of given expression. 2 raised by n plus 1 minus 1. 2 raised by k plus 1 plus 1. Then 2 raised by n plus 1 minus 1. So it's same as right hand side of the given expression for n is equal to k plus 1. Fine. So p of k implies p of k plus 1. That implication is true. So let me repeat the whole procedure again for this problem. So our problem was that if we have n powers of 2 starting from n is equal to 0, so this summation is equal to sum of these powers is equal to 2 raised by n plus 1 minus 1. So first we show base case for n is equal to 0. So for n is equal to 0, left hand side is equal to 1. हमारे पास एक ही 2 की पावर है 2 raised by 0, so which is equal to 1. Right hand side क्या है 2 raised by n plus 1 minus 1, so 2 raised by 0 plus 1 which is 2, so minus 1. 2 minus 1 is equal to 1. So left hand side is same as right hand side. So we make hypothesis. Suppose the given expression, given statement is true for n is equal to k, certain value of k. I mean, it's generalized value, it could be anything. So we just take k. So suppose the expression is true for k, then we need to show that it is also true for k plus 1. P of k implies P of k plus 1. P of k is our hypothesis. So based on this hypothesis, we have to show that P of k plus 1 is also true. So for P of k plus 1, this is our inductive step. We call it inductive step. So based on our hypothesis, we show this inductive step. So let's take n is equal to k plus 1. For n is equal to k plus 1, let's see whether the given statement is true or not. So sum of first k plus 1 powers of 2. Sum of first k plus 1 powers of 2. So 1 plus 2 plus 2 square plus 2 raised by k plus 2 raised by k plus 1. So इसमें जो पहली powers हैं up till 2 raised by k, value of this summation is given in the hypothesis. हमने क्या है कि suppose hypothesis is true. So जो information hypothesis की है वो हम use कर सकते हैं. बल्कि हमें use करना है because based on this hypothesis we are going to show statement is true for n is equal to k plus 1. So we must use the information of hypothesis. So 1 plus 2 plus 2 square plus 2 raised by k, जहाँ तक ये जो summation है इसकी वैल्यू हमारे पास hypothesis से given है which is equal to 2 raised by k plus 1 minus 1. So 2 raised by k plus 1 minus 1 और plus 2 raised by k plus 1 as it is आ गया. अब 2 raised by k plus 1 और 2 raised by k plus 1 ये तो एक ही चीज है. They are being summed up, added up. So 2 raised by k plus 1 plus 2 raised by k plus 1. It's just like x plus x, which is 2x. So 2 raised by k plus 1 plus 2 raised by k plus 1 is 2 times 2 raised by k plus 1 and minus 1 as it is हमने लिख लिया. So 2 raised by k plus 1 into 2 raised by 1. Base same है तो powers add हो जाती हैं. So it becomes 2 raised by k plus 2 and then minus 1. So 2 raised by k plus 2 is 2 raised by k plus 1 plus 1 and then minus 1. So it's same as the right hand side of the given expression with n is equal to k plus 1. With n is equal to k plus 1. So 2 raised by n plus 1 2 raised by k plus 1 minus 1. So the statement is true for n is equal to k plus 1. So अगर तो स्टेटमेंट k के लिए ट्रू है तो k plus 1 के लिए भी ट्रू है. So बेस केस ट्रू है, हमारा इंडक्टिव स्टेप ट्रू है. So it means the given statement is true for any value of n. So hence we say that it's true. In general, this expression is true. Let's do one more example. So this example is given. Formulate a conjecture for the sum of first n positive integers and then prove your conjecture using mathematical induction. So इससे पहले क्या था, हमें एक conjecture दिया हुआ था. इससे पहले जैसे sum of powers of 2 first n powers of 2 is equal to 2 raised by n plus 1 minus 1. या उससे पहले first of n integer sum of first n integer is equal to n into n plus 1 divided by 2. So a conjecture या फार्मूला हमें गिवन था. अभी इस क्वेश्चन में हमने फार्मूला खुद बनाना है. So conjecture a formula for the sum of first n positive integers, odd integers, first positive n positive odd integer. और फिर जो भी हम फार्मूला हम बताएंगे, we have to show it by mathematical induction that it is a valid formula. So first odd integer, पहला odd integer is 1. Sum of 1 is just 1. So अगर हमारे पास दो odd integer हैं, so 1 plus 3 is equal to 4. हमारे पास तीन इंटीजर्स हैं odd integers, तो हम क्या लिख सकते हैं, 1 plus 3 plus 5. So 1 plus 3 4 plus 5 is 9 and so on. So हमारे पास अगर एक odd integer है, so this sum is equal to एक odd integer है तो it's just one integer. So the sum is equal to 1. If we have two odd integers, so n is equal to 2. So दो integer हमारे पास कौन से होते हैं, पहला 1 है, दूसरा 3 है. So 1 plus 3 is 4. तीन odd integer 1 plus 3 plus 5 is equal to 9. चार odd integer 1 plus 3 plus 5 plus 7 is 16. पांच होंगे तो plus 9 हो जाएगा, 25 हो जाएगा. So from here we see it looks like this is equal to n square. अगर हमारे पास n की वैल्यू 1 है तो sum is equal to n square which is 1. n की वैल्यू 2 है तो sum is equal to 4. n की वैल्यू 3 है, तीन odd integer, so sum is equal to 3 square. n is equal to 4, so sum is equal to 4 square and so on. So we can make a conjecture for first n odd integer, sum is equal to n square. So in general जो हमारे पास odd integers होते हैं उनको हम क्या लिखते हैं, 2k plus 1 या 2n plus 1 कह लें, 2n plus 1. So या हम 2n minus 1 भी कह सकते हैं. जो भी हमारे पास even number है उसमें आप plus 1 करें या minus 1 करें, you will get an odd number. So अगर n की वैल्यू 1 है, so पहला odd integer is 1, so 2n plus 1 करने से तो वो 3 हो जाएगा. So it's better to use 2n minus 1. So n is equal to 1, so 2n minus 1 we get first odd integer. n की वैल्यू 2 है तो 2n minus 1 we get 3 second odd integer. n की वैल्यू 3 है, so we get 2n minus 1. 2 into 6 2 into 3 6 minus 1, so 5 we get third odd integer. So 2n minus 1 is right expression for nth odd integer. So n odd integer को अगर हमने ऐड करना, so it's 1 plus 3 plus 5 plus 7 plus 2n minus 1. So first odd n odd integer, their sum is equal to n square. ये हमारा conjecture हो गया. For first n odd integer, their sum is equal to n square. We need to prove it, that sum of first n odd integer is equal to n square. So ये हमारा conjecture है, इसको हमने prove करना है. So for proofs, first of all we need to show the base case. Base case हमने अभी वैसे ही show कर लिया पिछले जब हमने conjecture बना रहे थे. So if n is equal to 1, so it means first order integer, so left hand side is this 1 and right hand side is 1 square is equal to 1. Similarly we can show for like n is equal to 2 and n is equal to 3 and so on. So suppose a given expression is true for certain value of n, let's call it k, n is equal to k. जो हमारे पास पहले k odd integer है, their sum is equal to k square. So 1 plus 3 plus 5 up till 2 raised by k minus 1, हमारा kth odd integer. इन सब का सम इज इक्वल टू k स्क्वायर. So if this is true, then it should be true for n is equal to k plus 1. वो हमें show करना है. If p of k is true, if our statement is true for n is equal to k plus 1, then we should have p of k plus 1, means our statement for k plus 1 should also be true. Let's show it. So based on our hypothesis, we have to show जो हम show करते हैं इसको हम inductive step कहते हैं. So we have to perform inductive step. We need to show that the expression is true for n is equal to k plus 1. Yani k plus 1 odd integer ka sum should be equal to k plus 1 square. Let's see. So sum of first k plus 1 odd integer. K integer तो हमारे पास है 1 plus 3 plus 5 up to 2k minus 1. k plus 1 है तो हमें एक और odd integer add करना पड़ेगा. We know odd integer के दरमियान gap 2 का होता है. So next odd integer should be 2k minus 1 के बाद odd integer should be 2k plus 1. दोनों के दरमियान गैप 2 के हैं. एक 2k minus 1 है, दूसरा 2k plus 1 है. गैप is 2. So हमारे पास sum of first k plus 1 odd integer आ गया. लेकिन hypothesis है, हमें पता है जो पहले k integer हैं k plus 1 integers में से पहले जो k in odd integers हैं उनका sum is equal to k square. जो ये एरर में summation given है इसकी वैल्यू तो हमें hypothesis से मालूम है. So we can just substitute value of this as k square. From hypothesis we know the value of first summation of first k odd integer which is equal to k square. So this become k square और उसके बाद 2k plus 1 as it is आ गया k square plus 2k plus 1. So ये तो हमारे पास just formula है a square plus 2ab plus b square का k square plus 2 times 1 times k plus 1 square. K square plus 2k plus 1. So this is just a square plus 2ab plus b square. So we can write it down as k square plus 2k plus 1 is equal to k plus 1 whole square. So this is the same right hand side of the given expression with n is equal to k plus 1. हमें ये show करना था कि this is equal to n square. So when value of n square is when value of n is equal to k plus 1, so this should be equal to k plus 1 square. So expression is true for n is equal to k plus 1 as well. So अगर p of k true है तो p of k plus 1 भी true है. So it means it is true for all values of n. So sum of odd integers, sum of first n odd integer is equal to n square. It is true. It is proven. It is true. Let's do one more example and then maybe we can have a break. So next expression is about inequalities. अभी तक हम कह रहे थे वहाँ पे left hand side was equal to right hand side, equality थी. अब हमारे पास inequality है. So first inequality is it's quite simple, like n is less than 2 raised per n. Obviously for positive integers n should be less than equal to it should be less than 2 raised per n. एक साइड पे हमारे पास n linearly चीज बढ़ रही है, दूसरी साइड पे exponential चीज बढ़ रही है. So left hand side should be less than right hand side. We need to prove it. Inequality में एक चीज प्लीज ख्याल रखिएगा, inequality. So एक चीज कम है, दूसरी चीज बड़ी है. अगर जिस तरह यहाँ पे लेफ्ट हैंड साइड इज लेस देन राइट हैंड साइड, या लेफ्ट हैंड साइड इज लेस देन राइट हैंड साइड. सो अगर जो चीज छोटी है इसको हम मजीद छोटा करें तो इनइक्वालिटी वैलिड रहेगी. ये जो साइड बड़ी है इसमें हम मजीद कोई चीज ऐड करेंगे तो ये वाली साइड और बड़ी हो जाएगी, इनइक्वालिटी आपकी वैलिड रहेगी. सो दिस इज सिंपल प्रॉपर्टी ऑफ इनइक्वालिटी. जब हमारे पास इक्वल का साइन होता है उसमें हमें दोनों साइड्स को बराबर रखना होता है. सो जो चीज आप लेफ्ट हैंड साइड पे परफॉर्म करें इक्विवेलेंट चीज वी हैव टू परफॉर्म ऑन द राइट हैंड साइड. इनइक्वालिटी में हमारे पास थोड़ी सी फ्रीडम आ जाती है कि लेफ्ट हैंड साइड इज लेस देन राइट हैंड साइड. राइट हैंड साइड बड़ी है, राइट हैंड साइड बड़ी है, अगर इसको हम और बड़ा करेंगे तो हमारी जो इनइक्वालिटी है ये लेस देन ये फिर भी वैलिड रहेगी. या लेफ्ट हैंड साइड को अगर हम और छोटा कर देंगे तो हमारी इनइक्वालिटी लेस देन वाली वैलिड रहेगी. सो इनइक्वालिटी में अगर एक साइड बड़ी है उसमें अगर आप मजीद बड़ा करेंगे इनइक्वालिटी वैलिड रहेगी, उस पर कोई फर्क नहीं पड़ेगा। और इस तरह जो साइड छोटी है उसको अगर आप मजीद छोटा कर दें, इनइक्वालिटी पे कोई फर्क नहीं पड़ेगा। बाकी जो इनइक्वालिटी की प्रॉपर्टीज हैं कि इफ वी मल्टीप्लाइड बाय सम नेगेटिव नंबर, इनइक्वालिटी की डायरेक्शन रिवर्स हो जाती है, या अगर हम सेम चीज ऐड करेंगे या सब्ट्रैक्ट करेंगे दोनों साइड पे तो इनइक्वालिटी पे कोई फर्क नहीं पड़ता, वो सब चीजें दे होल्ड। So let's try to show n is less than equal to is less than 2 raised power n. So again same, we have to show base step. So n is all positive integers, so it means we have to start from n is equal to 1. So base case n is equal to 1. So if n is equal to 1, so हमारे पास left hand side पे n है, so left hand side is just 1, n is equal to 1. Right hand side क्या है, 2 raised power n. So this becomes 2 raised power 1 is equal to 2. So obviously 1 is less than 2. So left hand side is less than right hand side. So expression is true for the base case. Expression is valid for the base case. So next, our hypothesis, suppose the given expression is true for certain value of n is equal to k. हमारी कुछ वैल्यू हम कहते हैं n is equal to k के लिए ये ट्रू है, n is equal to k के लिए ट्रू है, so it becomes k is less than 2 raised power k. अगर तो k के लिए ट्रू है तो फिर k plus 1 के लिए भी ट्रू होने चाहिए, and this we have to show it. This we need to show it, this we need to prove it. So let's show it. Inductive step. So okay, so हमारा hypothesis k is less than 2 raised power k. So inductive step में क्या होगा? So we just start from the left hand side. k की जगह हमारे पास आ गया k plus 1. So left hand side is k plus 1. So यहाँ से लेकिन हमें पता है कि जो value of k है, this is less than 2 raised power k, hypothesis है. So from hypothesis we know that k is less than 2k. So k plus 1 के अंदर k की जगह हम replace कर सकते हैं 2 raised power k. और फिर जो हमारा एक्सप्रेशन है, this will become less than the value, क्योंकि एक साइड पे अब हम बड़ी वैल्यू डाल रहे हैं. So if we have like k plus 1, so k की जगह 2 raised power k आ गया, या सिंपली जो आपके पास हाइपोथेसिस है उसके दोनों साइड पे आप plus 1 ऐड कर लें. So this become k plus 1 is less than 2 raised power k plus 1, because k is less than 2 raised power k. So k plus 1 is less than 2 raised power k plus 1. So what we need on the right hand side is 2 raised power k plus 1. So हमें कुछ manipulation ऐसी करनी है, we should get the right hand side. So plus 1 है, अगर plus 1 की जगह मैं 2 raised power k replace कर दूं, so obviously 1 is less than 2 raised power k. So 1 की जगह अब मैं एक बड़ी चीज ऐड कर रहा हूँ. I'm replacing 1 with a bigger thing. So 2 raised power k plus 1, it is less than 2 raised power k plus 2 raised power k, because 1 छोटा है 2 raised power k से, 1 की जगह I replace 2 raised power k. So छोटी चीज की जगह मैंने एक बड़ी चीज को replace कर दिया. So k plus 1 is less than 2 raised power k plus 1, and this is less than 2 raised power k plus 2 raised power k. And we know 2 raised power k plus 2 raised power k is 2 times 2 raised power k, which is in turn equal to 2 raised power k plus 1. And then this is what we needed. So we can conclude k plus 1 is less than 2 raised power k plus 1. So hence expression is true for n is equal to k plus 1 as well. Again I repeat. So inequality में again remember this thing कि एक साइड आपकी छोटी है, दूसरी साइड आपकी बड़ी है. जो बड़ी चीज है उसमें अगर आप उसको और बड़ा कर देंगे वो बड़ी ही रहेगी, उस पर कुछ फर्क नहीं पड़ेगा. So we are proving our expression. So हमने जो बड़ी चीज इस तरह ऐड करनी है such that it should help us to reach our conclusion. So first हमने show किया base case 1 is less than 2, that was okay, fine. Then hypothesis, suppose it's true for n is equal to k. If it is true for n is equal to k, then it should be true for k plus 1. We need to show it. So if it is true for n is equal to k, k is less than 2 raised power k. ऑलवेज रिमेंबर जो हमारा हाइपोथेसिस है इसकी इंफॉर्मेशन हमने इंडक्टिव स्टेप में यूज करनी है, बिकॉज वी आर गोइंग टू शो P of k implies P of k plus 1. P of k implies P of k plus 1. So we need to use the information of hypothesis. We need to use the information of P of k जब हम prove कर रहे होते हैं. So for n is equal to k plus 1, let's see. So n की value k plus 1 हुई. So k plus 1, but we know about k. K is less than 2 raised per k. So k plus 1 should be less than 2 raised by k plus 1. So k plus 1 is less than 2 raised by k plus 1. लेकिन हमें राइट हैंड साइड पे 2 रेज्ड पर k plus 1 चाहिए. So 2 raised per k plus 1, so we can replace 1 by 2 raised per k. So if we because 1 is still less than 2 raised per k, so inequality is valid. So 2 raised per k plus 2 raised per k. So 2 raised per k plus 2 raised per k is equal to 2 times 2 raised per k. 2 times 2 raised per k, so we can write it down as 2 raised per k plus 1. बेस सेम है तो पावर्स ऐड हो जाती है. So it means k plus 1 is less than 2 raised per k plus 1. दरम्यान में inequality आ रही है. So k plus 1 is less than 2 raised per k plus 1. So hence the given expression n is less than 2 raised per n is true for n is equal to k plus 1 as well. k के लिए हमने सपोज किया था k plus 1 के लिए भी ट्रू है, so it's true for all values. Let's do one more example and then maybe we can stop. So our next expression is use mathematical induction to prove that 2 raised per n is less than n factorial. 2 raised per n is less than n factorial. ये हमने show करना है. So for अच्छा इसमें अब डोमेन सेट हमारा चेंज हो गया. n is greater than equal to 4. So n is equal to 1, n is equal to 2, n is equal to 3 के लिए ये वैलिड नहीं होगा. हमारा डोमेन सेट अब n greater than equal to 4 से स्टार्ट हो रहा है. So हमारा जो बेस केस होगा it should start from बेस केस should start from n is equal to 4. हमें n is equal to 1 के लिए शो नहीं करना because वहाँ पे obviously it will be false. So base case should start from n is equal to 4. So we need to show the base case. So let's try to show it. So base case if n is equal to 4. So be careful कि जो आपकी डोमेन सेट है उसके अंदर हमने शो करना होता है. लेफ्ट हैंड साइड इज 2 raised per n, so 2 raised to power 4 is equal to 60. And right hand side is going to be n factorial, so this is going to be 4 factorial. 4 factorial, 4 factorial we know is equal to 24. 24, so left hand side is less than right hand side is true. 16 is less than 24, so it is true. 16 is less than 24, so base case is true. यहाँ देखें अगर हम n is equal to 3 के लिए शो करें तो 2 raised by 3 is going to be 8 and 3 factorial is going to be 6, so 8 becomes greater than 6. So अगर n की वैल्यू आप 4 से कम लेंगे तो आपका बेस केस गलत हो जाएगा. वी हैव टू टेक जो डोमेन सेट में कंडीशन दी हुई है n is greater than equal to 4, so we have to start from n is equal to 4. So for base case it's true, left hand side is less than right hand side, 16 is less than 24. So suppose hypothesis, suppose our given expression is true for n is equal to k, means 2 raised per k is less than k factorial. Obviously k की वैल्यू हमारी अब 4 से बड़ी होगी. So 2 raised per k is less than k factorial. So we need to show that p of k implies p of k plus 1. कि n is equal to k plus 1 के लिए भी ये चीज true होगी. So we make our inductive step. So for inductive step, okay, yeah. इसको हम हटा देते हैं. ओके फाइन. तो let's show it for n is equal to k plus 1. Hypothesis, 2 raised by k is less than k factorial. So let's start from, we can start from either right side or left side. So let's start from left hand side. 2 raised per k, 2 raised per k plus 1. So n की वैल्यू अब हमारे पास 2 n k plus 1 है. So 2 raised per k plus 1. So 2 raised per k plus 1 can be written as 2 times 2k plus 2 times 2k, 2 times 2k. इसमें always remember we have to show the information of hypothesis. Hypothesis is helpful for us. अब hypothesis में हमें given क्या है? Hypothesis में given is 2 raised per k is less than k factorial. So we can write down. We have to extract this information from our inductive step. 2 raised per k plus 1 है, so we have to see के 2 raised per k हमारे पास किस तरह आ सकता है. So 2 raised per k plus 1 को हमने 2 times 2 raised per k कर लिया, so we get 2 raised per k. So we can use this information from hypothesis. We know that 2 raised per k is less than k factorial. 2 raised per k is less than k factorial. So we can use this information. So this is helpful for us. We can use this information. Okay. So let's use this thing. So 2 times 2 raised per k. So okay, 2 times 2 raised per, sorry, 2 raised per k plus 1 is equal to 2 times 2 raised per k. So this thing is less than 2. इसी तरह आ गया 2 times k factorial, because 2 raised per k is less than k factorial, so we replace 2 raised per k by k factorial. So 2 raised per k plus 1 is less than 2 times k factorial. What we need is k plus 1 factorial. So we 2 की जगह हम we can replace with 2 की जगह हम k plus 1 से multiply कर लेते हैं, because हमें पता है कि minimum value of k is 4, so k plus 1 की value 5 होगी. 5 is eventually greater than 2, so 2 की जगह हम k plus 1 से multiply कर लेते हैं, so k plus 1. So 2 is replaced by k plus 1 because k plus 1 is greater than 2. So k plus 1 times k factorial. So this is going to be equal to k plus 1 factorial. K plus 1 times k factorial is equal to k plus 1 factorial. So hence 2 raised per k plus 1 is 2 raised per k plus 1 is less than k plus 1 factorial. So this is what we were supposed to show. कि जो हमारा given expression है, it is true for n is equal to k plus 1. Again, I repeat the question and its solution. Our question was use mathematical induction to show that 2 raised per n is less than n factorial. जबकि n की वैल्यू हमारे पास 4 या 4 से बड़ी है, n is greater than equal to 4. So base case हमने n is equal to 4 से start करेंगे, because it's given in the question. हमारा domain set n is greater than equal to 4 है. So first case is base case is n is equal to 4. So 2 raised per n, 2 raised per 4 is equal to 16, and n factorial is 4 factorial is equal to 24. So 16 is less than 24. It is true. It's valid. Base case is true. So let's see for hypothesis. So hypothesis, suppose our expression is true for n is equal to k. So 2 raised per k is less than equal to 2 raised per k is less than k factorial. 2 raised per k is less than k factorial. So if expression is true for k, then it should be true for k plus 1. Let's show it. So expression is true for k. 2 raised per k is less than k factorial. So it means I mean we are going to show it for k plus 1. So let's take the left hand side. For n is equal to k plus 1, left hand side becomes 2 raised per k plus 1. And 2 raised per k plus 1 को हम लिख सकते हैं 2 times 2 raised per k. So, but from hypothesis we know 2 raised per k is less than k factorial. So we can replace 2 raised per k by k factorial. So हमारे पास inequality आ जाएगी 2 into 2 raised per k की जगह हमारे पास आ जाएगा this thing is less than 2 times k factorial. We need k plus 1 factorial over here. So अगर हम 2 को replace कर दें k plus 1 से, because we know कि k plus 1 is greater than 2. k की minimum value 4 है. So 4 is greater than 2, k plus 1 is 5, so 5 is greater than 2. So k plus 1 is greater than 2. So we can replace 2 by k factorial. So ये वाली जो हमारे पास right hand side है, ये मज़ीद बड़ी हो जाएगी. So we can write down k plus 1 times k factorial, which is equal to k plus 1 factorial. So हमारे पास right hand side, left hand side से still बड़ी है. So right hand side is 2 raised per k plus 2 raised per k plus 1. So this is less than k plus 1 factorial. So this inequality holds. So it's true for k plus 1. So it's true for any value of n.